Okay, so this is the second quadratic word problem. So this one, the height in feet of a water balloon over time in seconds is given by the height based on time is equal to negative 16t squared plus 64t plus 5. So I want you to tell me the story and sketch the graph. So like last time, we talked about how you have a beginning, a middle, and an end to a story. And for the first part of the story, what you're looking at is the beginning. And the beginning is at time 0. So what's going on after 0 seconds? So when you plug in 0 into the function, what you find, just like last time, is that you're going to end up with just this last number. And it does always work that way. C is always going to be your y-intercept. So after 0 seconds, the water balloon is 5 feet. And that makes sense, because if you're a person tossing an underhand toss, it seems like it would leave the ground, or be pushed into the air around 5 feet. So the water balloon, the story, left, well, you know what, it'll be Joe. Well, let's say it left Joe's hand at a height of 5 feet. Next, we're worried about the middle part. What happened after it left his hand? Well, to find that out, we need to know the maximum height and when that happened. So negative b over 2a, that'll give us the time that the max height occurred. So that's a negative 64 over 2 times negative 16. Negative 64 over negative 32 gives us positive 2. So after 2 seconds, it hits max height. And what was that? We'll plug 2 in for time. So h of 2 and that'll give us a height of 69 feet. So it reached its max height and then lastly, we want to know when did it hit the ground. And on my last drawing, I totally forgot to draw the cannonball, and I really wanted to. So this time, I'm going to make sure I draw Joe. So here's Joe and his water balloon, and I'm not that great of an artist. Okay, that's his water balloon. And so it's going into the air. That's at 5 feet. It goes up and hits after 2 seconds, after 2 seconds, it hits a maximum height of 69 feet. This is y, everything's in feet there, and this is x, everything's in seconds. Okay, and then it comes back down, and we want to know when. Well, you've learned how to do that. So what you do in your calculator, well, you could use the quadratic formula if you wanted to, but for this it's easier just to get an approximation by using your calculator. Do second trace 5, enter 3 times on that x-intercept. Make sure your y2 is equal to 0, and you'll find that it hit the ground after approximately 4.0 seconds. So gravity 1, and the water balloon hit the ground after 4.077 seconds. Okay, great. And Joe's happy because he survived the problem, and his water balloon also was fun to throw. Okay. You'll be trying some of these in just a moment. Great.